Hello PLP Geometry and welcome to the beginning of Unit 6. Our Unit 6 is going to cover circles. So circles is its own kind of standard in the geometry course. So again, the state test is going to ask you for questions involving circles. So we'll take a couple lessons here and talk about some circles. Now, to kind of continue where Unit 5 left off, our first lesson in Unit 6 is going to be circles in the coordinate plane. So number 1 here, circles on the coordinate plane. So it's a nice little transition here into talking about circles on the coordinate plane. Okay, so let's talk about what the definition of a circle is. So again, I think you know what a circle looks like, right? But the definition, so a circle. So by definition, a circle is the set of all points in a plane. And again, that in a plane idea just means it's two-dimensional, it's flat, right? In a plane, equidistant. And again, in parentheses, I'm going to put the word radius. So equidistant, and in parentheses, radius, to a given point. And in parentheses, I'll put the word center. So a circle is the set of all points in a plane equidistant radius to a given point center. So here is my circle that I'm going to draw. It will have a center, and I'm going to label it C. So we would call this circle C, and here's the symbol. So we would use a circle symbol. It's a circle with a dot and then a capital C, right? And again, that's pronounced circle C. Now, I'm going to draw a radius from C out to the circle. Let's call that point X. So in this case, a radius is the distance from the center out to the circle. So segment CX would be a radius. The diameter then is going to be a segment that goes all the way across the circle through the center. So I'm going to draw a diameter from here through C down to here. Let's call that endpoint Y. Let's call that endpoint Z. So then the diameter in this picture is going to be segment YZ. Now, if we take a look at this diameter, there are two radii that make up this diameter. So C to Y is one radius. C to Z is another radius. So your diameter is equal to 2 radii, which means that your radius is equal to 1/2 of the diameter. And there's your relationships. So this is your background knowledge on what a circle is. Now, what about in a coordinate plane? Well, let's take a look at the equation of a circle, because algebraically, a circle has an equation. Okay, so the equation of a circle. So the equation of a circle. So if a circle has a center at a point h, comma, k. We don't want to use x and y. We use h and k. And a radius equal to r. So it has a center and it has a radius. Then the equation is going to be this, parentheses, x minus h squared plus parentheses y minus k squared equals r squared. This formula needs to be memorized. The state test doesn't give it to you, so I'm not going to give it to you, right? But if you think about this formula just comes from Pythagorean theorem. And I'll show you on a picture what I mean. Pythagorean theorem. And we talked about that in Unit 4. But again, it's something squared plus something squared equals something squared. Okay, so in the coordinate plane, right? So I'm going to draw my axes like this. I'm going to draw my circle in purple, and let's draw it like this. Something like that, right? So I'm going to put my center right here, and I kind of want to just keep it out of the first quadrant just to be a little bit different. So let's call that my center, and that point right there is my center at HK. And then let's draw a radius to this random point. So let's call this random point XY. Let's draw that dotted segment, and there's the radius. Okay. So again, this Pythagorean theorem comes from dropping a vertical down and a horizontal to the right. Again, this right here is the length of x minus h. This right here is the length of y minus k, and then your r. And there are your three pieces for the Pythagorean theorem. X minus h squared plus y minus k squared equals r squared. So there's your Pythagorean theorem. Okay, so let's see if we can do three examples involving this equation of a circle. Okay, so example 1 says determine the equation of the circle. Determine, let me use shorthand, equation of circle. And what they're going to do is they're going to give you a picture. So I'm going to give you a picture as well. Okay. So I'm going to tell you that there's a point right here at negative 1, 1, 2, 3, 4, 5. Negative 1, 1, 2, 3, 4, 5. So there's a point there. And then I'm going to tell you there's another point right down here. There's a point over here, 1, 2, 3, 4. 1, 2, 3, 4, 5. So right here. There's a point 1, 2, 3, 4, 5 right there, and then 1, 2, 3, 4, 5 right there. Okay, so there is your circle. Okay, and you need to find the equation of this circle. All right, so first and foremost, I'm going to write down my formula, right? So x minus h squared plus y minus k squared equals r squared. Again, write that down a bunch of times, and you'll learn it really quick. Now, let's identify our center, which is the h and k. So my center. So your center is this point right there, and your center is at negative 1, 5. Okay. Next, let's identify our radius length. Now, in this case, they're going to, I think, show you a second point somewhere. So I'm going to put a point right there, right? We are simply going to count this horizontally. 1, 2, 3, 4, 5. That radius is a length of 5. This length is 5. So again, you should be able to count. We'll do an example where you can't just count, but for this one, you'll see you should just be able to count. So now we're going to plug in our numbers. So this is my h, this is my k, and that's my r. So x minus negative 1 squared. Notice the minus minus because your h is negative. Plus y minus 5 squared equals 5 squared. So the minus minus becomes a plus, so we have x plus 1 squared. The y minus 5 squared stays alone, and then we like to actually simplify. 5 squared is 25. And there is our equation of the circle. Okay, next one, example 2. All right, so again, we're going to determine the equation of the circle. So here's another picture. Okay, so 2, negative 2, we have a point, and then 9, 1. So 2, 3, 4, 5, 6, 7, 8, 9, 1. So there are our important points, and we're going to draw a circle through this point 9, 1. So I think they'll be labeled for you. So 9, 1, 2, negative 2, and again, I'll draw a circle as best I can going around there. Just do your best, whatever. Okay, so now, again, I want to find my equation. So my equation of this circle is x minus h squared plus y minus k squared equals r squared. So I want to identify my center, and they do, right? My center is this point, 2, negative 2. 2, negative 2. Now my radius, on the other hand, this is more difficult to find because our radius is not a nice number. We can't just count. You'll see that the circle doesn't go through nice points if you go right or up or down or left. So we have to connect to this point right here. That is our radius. Because our radius is angled, we have to use our distance formula from unit 5. So to find the radius, we're going to use the distance formula, which I taught you was x squared plus y squared inside a square root. And remember, to create the x and y, you need to draw a right triangle. So there's my right triangle. This is my x distance. This is my y distance. So to go from 2 to 9, I would go 1, 2, 3, 4, 5, 6, 7. So my x distance is 7. To go from negative 2 to 1, I'd go 1, 2, 3. My y distance is 3. So my radius here is going to be 7 squared plus 3 squared. That is 49 plus 9. The radius is the square root of 58. There is no need to simplify that. Leave that alone. That is your r. You're done with your r, right? 2 and negative 2 are my h and k, and now we just plug it into the formula. So let's see. So x minus 2 squared plus y minus negative 2 squared equals, and my radius is the square root of 58, and I'm going to square that. Okay, so what happens to my x minus 2? Nothing. So it's just x minus 2 squared. My y minus negative 2 becomes y plus 2 squared. And then my square root of 58, when I square it, the square root and the squared cancel, and 58 just pops out. And there would be my equation. Okay, last but not least, right? Final example here, example 3. Okay, so example 3, we're going to actually graph the circle. Okay, so they're going to give us an equation. Our equation here is x plus 3 squared plus y minus 8 squared equals 4. Okay, so before I graph it, I need to come up with the key things. I need the center and the radius. So what I will do is I will draw or write my general equation below. X minus h squared plus y minus k squared equals r squared. Now, how do we do this backwards? Well, we need to take a look at these signs. Notice that this x has a minus sign after it, but the one they give us is a plus sign. The reason that that is a plus sign is because this really says x minus negative 3. Two negatives make that positive. So your h value is really a negative 3. So for my center, my h value is a negative 3. So notice it's backwards of the sign they give you. This says x plus 3, it's a negative 3. Now in this case, my y is a minus, and that y is a minus, so your k is just the 8. So it is positive 8. So there's my center. Negative 3, positive 8. Again, that's my h and k. Now, to find my radius, I need to look right here. 4 is not my radius. 4 is my radius squared. R squared equals 4. To find the radius, we must take the square root. And when you take the square root of 4, you get a nice number of 2. So these are the two things I need to then draw my circle. So let's come over here. I'll draw a coordinate plane. I need to go to the left 3 and up 8. 3, 4, 5, 6, 7, 8. Okay. And now, to graph this circle by hand, I need to count a radius of 2. I'm going to do it in all 4 directions. Now, using software technology, I think if you just do one direction, they will graph the whole thing for you. But I will do all 4. So from this, I'll go 1, 2 to the right. I'll go 1, 2 down. Let me add 2 markings down here. I'll go 1, 2 to the left. Let me add 2 markings there. I'll go 1, 2 up. So now I have those 4 points on the circle that are created by going horizontally and vertically. And now I can connect those with a circle. Now I want to show you two things, right? I'm going to come back to this in a second. I want to make a special note down here in green. Special note. Okay? If your equation has no parentheses, so x squared plus y squared equals r squared, right? If you see this, what this means is that it's really x minus 0 squared and y minus 0 squared, which means that your h and your k are really 0 and 0, which would mean for a circle with no parentheses, both the h and k are zeros, so your center is at the origin 0, 0. So keep that in mind when you do these problems. If one of the variables or both don't have parentheses, that variable of the center is a 0. Okay? So that's an important thing to make. And then lastly, I'm going to show you how Desmos graphs this for you, right? So again, state test, Desmos, 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 right? So let me go to Desmos. Okay. So in Desmos, I'm going to type in that formula they gave me. So it was parenthesis x plus 3 squared plus parenthesis y minus 8 squared equals, and it was 4. And boom, look at that. And you can see that my center was at negative 3, 8. And you can graph it. And then again, if you click on that circle, there's a point 2 up, a point 2 down. I'm surprised you don't put the points. I kind of label it point to the left and point to the right. All right, so circles in a coordinate plane. Big idea for the state test. Best of luck.